Hello class and welcome to Module 7, Connectivity Verification. This will be a nice, hopefully short and sweet section where we're just talking about the ICMP protocol suite that's used for pretty much verifying that one thing can talk to another. So let's go ahead and just jump right into it here. So no labs in this section either, so just a quick lecture here. So connectivity verification, we're going to talk about ICMP, explain how it's used to text network connectivity. It's pretty much a protocol suite that's exclusively used just for two hosts to be like, hey, can you hear me? Yes, I can hear you. Okay, great. It's pretty much like the first thing you do, the protocol suite you grab for when you're just making sure that something can talk to something else, either on another network or on the same network, or even, say, a local connection, just making sure that information is flowing. And then ping and traceroute utilities. These are some Windows tools that you can use. We've already talked about traceroute. To follow the connection, you can maybe see, say, it gets halfway there and then it breaks at one point. Maybe that's a router or switch or whatever you misconfigured or is misconfigured. So traceroute is helpful for, while ping will just say, hey, we're not getting any response. Traceroute will show you where that, breakdown of communication happens. Okay, so ICMP first, getting a little ahead of myself. The TCP suite provides message to be sent in the event of certain errors. So again, these are often if a connectivity fails or a message gets dropped. These messages are sent using services of ICMP. The purpose of these messages is to provide feedback about issues. So they're mainly for troubleshooting, or again, if somebody's trying to send information, then you get, an error kickback. It's most of the time it's being sent through ICMP. So they're not required and often not allowed within a network for security reasons. You could flood someone with ICMP messages and pretty much take up all their ports, and their computer's too busy responding to pings rather than anything else. So it's normally used initially for setting up, verifying the network, and then it's locked down behind either an admin account or just fully disabled. So it's available both in IPv4 and IPv6. ICMPv4 is for IPv4, and ICMPv6 is for IPv6, right? So a little bit of additional functionality. That's kind of just the story of IPv6. Everything's just a little better in terms of functionality. So the messages are both common in ICMP 4 and 6, which includes host confirmation, destination or service unreachable, and then time exceeded and route redirection. So pretty much just the good stuff you need to know is the host there? Is the destination there, or is it not? Or a specific service or port that's unreachable. Time exceeded, so if it's time to live, if it's floating around the network and pretty much just getting tossed either in a circle. So sometimes you might have an issue with routing where a message just keeps going around in this big network circle until it eventually falls. It's time to live, which then it's deleted off the network, and then it tells the original destination, or I'm sorry, the original person who sent it, hey, I couldn't find my way home or to the destination, and then obviously route redirection if, say, a network segment falls off, and then you go through a different means, so it still reached it, but you were redirected. So it might be important to say, oh, hey, wait, maybe a switch went offline or something. Okay, so host confirmation, this is pretty much, I would say, the most common use is the ping command at your host destination. So you can see here the echo request, which is asking, hey, can you send me back an echo or a ping and say, are you there? So we're pinging this destination IP, and you can see it's on the other side of the network over here. So the local host, which is 192.168.10.1, is trying to talk to 192.168.30.1. So the local host sends an ICMP echo request to a host, or a ping. If the host is available, the destination host replies with an echo reply. So again, echo is literally just, are you there? The reply is, yes, I'm here. This use of the ICMP echo messages is the basis of the ping utility. Again, this is kind of our bread and butter with ICMP, is just these pings, because it's the quickest way just to verify, you have your routers going to the correct networks. The default hosts or default gateways are working to be able to cross networks. You're able to cross into another switch, and the switch is routing correctly, right? So it's the easiest way. You just go from the furthest side of a network to the other side of the network and see if things are working. If any of you have done Packet Tracer, you're probably very familiar with ping. There's a really good option to turn it off real time and just have it do step by step, so you can send the ping command on one console and then click through and watch the little envelope move through the network and make its decisions piece by piece. It's very helpful for visualizing networks. So destination or service unreachable. So when a host or gateway receives a packet that it cannot deliver, so the packet tries to go somewhere, a certain port, say it's some FTP packet or whatever, or it's trying to talk to an FTP service that's closed, it can use an ICMP, a destination unreachable message to notify the source that the destination or service is unreachable. So pretty much packet full of fun FTP content tries to go to the port of an FTP host and destination, and it goes, oh, I can't deliver here. There's, port's closed, no one's home. Rather than sending back an FTP error message, most of the time it'll send it back an ICMP, destination reachable, because it's more lightweight and it's more likely to actually get back to where it's supposed to, because ICMP is pretty much supported everywhere. So the message will include a code that indicates why the packet cannot be delivered. The destination unreachable codes are the following. So unreachable network, unreachable host, which is 1, protocol unreachable, or the port unreachable, so the port's closed in 3. So ICMP v6 has slightly different codes for destination unreachable. I assume they'll show us that in a minute. An ICMP v4 time exceeded message is used by a router to indicate that the packet cannot be forwarded because the time to live TTL field of the packet was decremented to 0. So that's what I was talking about, is if a packet gets stuck in a whirlpool of just being rerouted and rerouted and rerouted, typically because, again, you have a cyclical route issue, all these packets typically have a stamp on them, which is how long they're allowed to exist in a network, which is their time to live. And every time they make a hop and move to a new place, that time to live is decreased. So if it's decreased to 0, that means, hey, this has been floating around our networks too long, it's meandering and not going anywhere, or wherever it's trying to go is too far, or outside of the scope of its time to live, so it gets decremented to 0, and then ICMP goes, hey, we send something back to the original host who sent it, that it didn't make it through the network. So ICMP v6 also sends time exceeded message if the router cannot forward an IPv6 packet because the packet has expired. So IPv6 does not have a TTL. It uses the hot limit field to determine if the packet has expired. So rather than having its own TTL field, they kind of streamlined it by just checking the hot limit field, right? So ICMP-v6 RS and RA messages has new features and improved functionality not found in the v4 version. IPv6 messages are encapsulated in IPv6. Makes sense. It has 4 new protocols as part of the Neighbor Discovery Protocol ND or NDP. Messaging between a router and a device has solicitation, so looking to see what routers are available. Advertisement at routers saying, hey, I'm available to be able to be talked to. Messaging between IPv6 devices, so neighborhood solicitation and neighborhood advertisement. This is pretty much how they can find each other on a network without actually requesting or sending a packet or a broadcast. They can solicit each other and advertise that they're present and ready for connections for whatever the port or service or just the host in general. So RA messages are sent by routers to provide addressing information to hosts using stateless, address, auto configuration, or Slack. So a router will send an RA message, so this is the advertisement. So it's pretty much, again, it's like running an ad saying, hey, we are offering routing services. Come on by. It's totally free. It just costs, electricity, I guess. A router will send this message periodically, so just kind of like generally, if a new host is joining a network, eventually it'll pick up that this router's here, because it just kind of every once in a while you can set for how often it actually advertises itself. But sometimes you can do a solicitation, so router solicitation. This is specifically asking on the network, like a broadcast, hey, is there any routers out there? So a host using Slack will set its default gateway to the link local address of the router that sent the advertisement. So it immediately associates with that advertisement, and then there's your default gateway setup. You don't have to, kind of like in IPv4, you'd have to actually go set your default gateway and point it to the right direction. Router advertisement, or if you have Slack on your router, a lot of the times the host can get the default gateway automatically now. So when a host is configured to obtain its addressing information using Slack, the host will send an RS message. So pretty much as soon as the host connects and it's set with Slack, it'll send that solicitation message to a router requesting its default gateway and information. So RS and RA messaging continued. Address resolution messaging between devices. NA messages are sent when a device knows the IPv6 address of a device but does not know its MAC. So again, we're here on the network level. We know the IP address, but we don't know its actual MAC or physical address, so we have to go down a level. This is equivalent to an ARP request, so address resolution protocol for IPv4. So they do this advertisement and solicitation rather than these broadcasts and making ARP tables, right? That's kind of the additional functionality and streamlining that you get from IPv6. So the advertisement message includes its MAC, so it pretty much goes, hey, here I am. This is my IP address that's matched with my MAC. Okay, duplicate address detection, or DAD. When a device is assigned a global unicast or link local unicast address, the DAD is performed on the address to ensure it's unique. To check the uniqueness of an address, it sends a solicitation to its own IPv6 address. If anyone else responds to that solicitation besides themselves, then you have a problem. There's a duplicate address, and if it does respond with the advertisement address, that the address is in use. So for the most part, I believe that it would just keep you from using that address. But if no one says, hey, no one solicitates their advertises their own address as that same address, then it's unique and then acceptable, right? So I'm pretty sure when if you are trying to set this address and this happens and it receives a corresponding advertisement of the same address, it just won't let you set it. But sometimes it's not as smart, so it's good to watch these messages. That's why they're important in ICMP. They'll kick back a message saying, hey, this is not an acceptable use address because it's already in use. So the unicast won't work because now it's going to go to two different things. Unicast is only supposed to go to one place, right? Okay, so ping and trace route utilities. Here's a video. Go ahead and watch it in the Netacad. Pretty much just saying how to use these network and testing verification using Windows CLI. So again, I know some of you don't have a Windows computer, but I recommend either getting on your VirtualBox evaluation so that you can mess with these Windows tools, or DigitalOcean, or whatever you want to do to spin up Windows VM. So ping, test connectivity, we already talked this a little bit, but ping is an IPv4 and 6 testing utility that uses the echo request and echo reply to see if things are there. Again, requesting is, hey, are you there? Replying is, yes, I'm here. So use the ping command, enter the IP address, see if you get a reply. So after all requests are sent, the ping utility provides a summary. So type of connectivity test performed, pinging the local loopback, so seeing if you're continuously getting responses, pinging the default gateway, making sure the gateway is active and able to receive packets, and then pinging a remote host, so someone else on another network. Okay, so ping the loopback. It can be used to test the internal config. So you just go to the local loopback. So this is the one for IPv4. It's your local address. For IPv6, it's ::1. So if you remember the shorthand of IPv6, it's 00000000000000001, right? So :1. So this is the shorthand for it. Easy to type in, a little faster for once than IPv4. Most of the time, IPv6 address take a little longer, but there's a small improvement there. And then the response tests the IP down through the network layer. So we're going to make sure that our IP is set correctly, and then it'll tell us if it's not operational, if it can't communicate on the network or not. So pinging the default gateway, like I said, you're just making sure a network's ready to accept packets. If it can't do a ping, then it's not ready for any other kind of packets to go through it. And then the host pings default gateway, sending the echo request. The default gateway sends an echo reply. This is like typically one of the things you first do. You configure your router, you connect it to the network via switch, like right here, and then you immediately go to a host to make sure that the host can ping through the gateway. Because again, this is kind of where you start, like when you're connecting to another network. Everything has to go through that router at the top, right? You can see here. So it's important that these default gateways, F1 and F0, are set correctly. So you can, again, just check it really quick with a ping. I hope some of you have done Packet Tracer. I believe one of the advisory courses has Packet Tracer as a focus. So it's a lot easier. Again, this isn't a networking class for us to dive super deep into it. It's a lot easier when you're using Packet Tracer, and if you feel like doing a little, extra credit or self exploration for Packet Tracer, I do recommend you download it. There's a lot of free network tests you can do. but generally just opening it, taking a router, taking a switch, taking two host machines, and then connecting them that's a great just starting exercise, and it's a lot more intuitive, in my opinion, to see the packet flow through rather than just like listening / reading all of this text. Again, not a networking course, and I know there's already plenty of labs, right? So we don't need more. So ping is used to test connectivity, but it doesn't provide the details. So again, it doesn't tell us the whole story. It just tells us the beginning and the end, which is, are you there? And yes, I'm there. Traceroute will show us all of the, hops, all of the destinations this packet took on its way to Mordor. So round trip time, RTT. Traceroute provides how long it took for each hop. So again, you can see if maybe there's a timeout, how long it timed out, or if there's excessive packet or traffic congestion in a certain part of your network. You can see that on the round trip time. And then asterisks, you can see if something got dropped. It's just the shorthand. So this information can be used to find the problematic router. Again, instead of pinging, let me go to the next slide so I can show you. So if you're here and you're trying to ping here and it just says it's failing, it's not particularly going to tell you, is it this switch? Is it this router? Is it this router? Is it this router? Is it this switch? Or is it the host, right? All I know is it doesn't work. That's not particularly helpful. That's why traceroute is very helpful, to be able to see exactly where you're failing. Just pretty much what this says is the time to live field and the hop limit and layer 3 headers exceeded message. It got stuck somewhere here. It bounced around too much, went too far to get to this other network, and therefore the packet was kicked back. Or the failure message was kicked back. So here's the ICMP packet. As with anything going through our network, they're all packets at the network layer. So you can see it has its own little data payload. It uses the codes to differentiate between the different kind of messages. So 0 is an echo reply, destination unreachable. These are all the error codes / the code it uses to figure out what kind of ICMP packet is being sent back and forth. Okay. Oh, you know what? We do have a packet tracer lab. Let me see if I have that posted. Give me 1 second. All right, welcome back. So yeah, sorry, I thought we didn't have a lab in this section because in my lab overview it didn't show one, but we do actually have packet tracer, which is excellent. So I guess my wish came true. Maybe your nightmare. Consider it how you will. So I will have this posted, this link here, where you can go ahead and download it for whichever version. So for Windows users, Linux, if you want to download it on your Linux machine, I suppose, and then for Mac users, right? So here's the addressing table. You're pretty much just going to open up PC1, PC2, and ping one another and do a traceroute really quick, super easy, and it's already set up. You just have to download the PKA file, and then once you have Packet Tracer installed and double click it, it'll open it. It's all already set up. You just have to ping back and forth pretty much. That's it. So great. I guess we do have a lab for this section. Again, I apologize for the misinformation there. But Packet Tracer, as I was mentioning, is super powerful, and again, way easier to understand what's going on when you are opening it and running that simulation rather than just looking at the diagrams here in the lecture. All right. That is the end of the lecture as well. So I will see you in Module 8. If you have any questions, go ahead and let me know. Have a good one.